Welcome to the screencast for Computing Machinery and Intelligence by Alan Turing. You can find this article on page 161 in our textbook. Many of you have probably heard of Alan Turing. He's best known for cracking the German Enigma machine in World War II, which really helped out the Allies so we could intercept and understand their messages. He was a brilliant mathematician, logician, scientist, and philosopher. You may have also heard of the Turing Test. This paper that we're going to look at describes what the Turing Test is, and it asks what it means when a computer passes it. Turing thought that this test, coming out of something called The Imitation Game, also the name of the movie about his life, meant that a computer was acting closely enough to a thing that thinks to count as something that thinks. So the underlying question is whether or not machines can think. First, of course, Turing, as a good, careful philosopher, says that we need to define what we mean by machines and define what we mean by think if we want to know if machines can think. But we can't use a common understanding of either word because this would be committing the logical fallacy of appealing to popularity, which means that concepts, their meanings, can never be defined just by taking a poll, because that can change. And whenever we're looking for the definition of something, we want to pinpoint with accuracy what we mean by it. Now, you may or may not agree with this. This might not be the case with linguistics. We do have to have some limitation in whatever it is we mean in any given time, but we all know that language does change. But Turing tries to sidestep this problem altogether when he says he can move on to a new question that comes in the end to the same thing. So if the original question is, can machines think? Turing thinks that this next question that he proposes will come back around and answer that question in the affirmative. But before we know what the question is, we have to take a look at Turing's thought experiment that he calls the imitation game. He tells you to imagine that there are three people: a man who we'll call A, a woman who we call B, and an interrogator that we call C. The interrogator, C, is in a separate room to both A and B. And Turing says you want to eliminate all of the identifiers. So you're just typing on a keyboard to the people in the other room. So there are no visual markers, there are no auditory markers. So C can't tell which one is a man and which one is a woman. And his goal is to ask the people questions to guess which of A and B is the man and which of A and B is the woman. Now, A, the man's job, is to confuse the interrogator. So he'll always be lying. And B, the woman's job, is to assist the interrogator. So she's always telling the truth. Now you can see that there's a problem because both A and B will say that they're the woman, and if they're perfect at their jobs, the interrogator will be confused as to who is the man and who is the woman. Now you can imagine, after you have the basics of this game set up, that instead of a man for A, the deceiver, you have a computer in its place. So Turing thinks that if A, as the computer instead of the man, could convince the interrogator that they were human, this is functionally the same thing as saying that the computer is thinking. It functions in the same manner as a person trying to convince an interrogator of some fact. So if we could ever program a computer to be sophisticated enough to always fool people into the idea that they're thinking, then why shouldn't that behavior count as thinking, no matter what's happening on the inside of the program? Because it acts the same way in the world. So you can remember when we thought about internal experience and how we can never enter the internal experience of other animals. So what makes machines different? Turing thinks that it's nothing. There is no difference. If the behavior was sophisticated enough, it should count as thinking. So also, like a good philosopher, he considers counterexamples to his thesis, and he offers premises to knock down those counterexamples. So on page 162, he has the argument from consciousness. So it's something similar to the what it feels like. We might not be able to enter into the inner experience of other animals, but we assume that they have it. When you talk to other human beings, you think that they have a rich inner life just like yours. And there's something that it's like to taste strawberries. There's something that it's like to stub your toe. And the people who say that computers could never count as thinking because of consciousness often bring up art and music as activities that only a thinking human, a thinking and feeling and experiencing human could possibly produce. But Turing thinks that if we could produce this hypothetical computer that's sophisticated enough to write sonnets and answer questions about their sonnets, why would there be a difference? He has a little dialogue here about an interrogator asking the witness, who we know is a computer, to explain one of Shakespeare's sonnets about "Shall I compare thee to a summer's day?" and tries to confuse the computer into showing that it doesn't really understand the meaning behind the metaphor, but the computer gets it and avoids the trap the interrogator lays out. So why shouldn't this sophisticated computer count as producing art? And Turing notes that this is the same way we do it with other people. If someone produces art and we ask them questions about it, we assume that they produced it. They produced some kind of beautiful art because of the capacities inside themselves. Why shouldn't it be the same for a machine? The next counter-argument that Turing considers is the argument from various disabilities. And this kind of argument boils down to, you've never been able to make a machine do X before, so why should you be able to do it in the future? And there's a long list on the bottom of page 163. I've only reproduced some of them, but I can speak them a lot less space-saving here. You can't program a machine to be kind, resourceful, beautiful, friendly, have initiative, have a sense of humor, tell right from wrong, fall in love, have as much diversity of behavior as man, do something really new. So we can all think of lots of these human, sophisticated behaviors that seem really hard to reach for a computer. But this is a fallacy. You can call it a fallacy from ignorance. The way he puts it, Turing, is that we learn inductively. If you think all the way back to the beginning of the semester, we talked about inductive reasoning and how once we're confronted with many examples of something, we tend to think that we've learned about the causes and the effects and the way the world works. So you can go back to the white swan example. If you've run into 100 swans and they're all white, you might feel confident in saying all swans are white, but that's just because you haven't had all the experience that there is to have about swans. So in the same way, we've had a lot of experience with machines in our life, and they're all way too simple to be kind or resourceful or have initiative or do something new. But that doesn't mean it's not possible. It just means it hasn't happened yet. And that a machine might be able to produce this kind of complex behavior in the future. One disability that Turing singles in on as curious, I think he says, is that computers don't make mistakes, while human beings do. And that would mean that the interrogator could eventually never be fooled, because all the interrogator would have to do is ask a complex arithmetical operation, and people will make mistakes in it, computer will not. Turing says, since the computer's trying to fool the interrogator, all it would have to do is make some mistakes, pretend to make mistakes. But moreover, and more importantly, there are two kinds of errors. There's error of functioning and errors of conclusion. So an error of functioning, like a short in wires or a breakdown of parts, we tend to ignore. And of course, computers are susceptible to those kinds of errors. And errors of conclusion only come into play, Turing says, once you already have meaning in a statement. So a calculating machine isn't imbuing meaning to any statement, whether it's arithmetical or about art. And that when you slip in making mistakes of conclusion, you're already assuming or begging the question that the computer can think. So Turing thinks by setting up these three specific counterexamples and then taking them down, he has reinforced his conclusion that it is possible for some theoretical machine in the future to pass the Turing test. And he thinks that proves that machines could think, or at least provides good evidence to say that if the behavior ends up being out there, that's sophisticated enough to fool the interrogator, that should at least be a strong piece of evidence that a computer, whatever its internal processes, is doing something that should count as thought.